All right, y'all. So 7-1 is a fairly short section, and it deals with symmetry. All right, there's three types of symmetry we're going to look at on our graphs. So, y'all, the first type of symmetry is what we call symmetric to the y-axis. All right, y'all. So being symmetric to the y-axis, if you can fold the graph, so if folding the graph over the y-axis, and the graph lands on itself. So, y'all, it's like the y-axis is splitting the graph in half so that when you fold it over that y-axis, that right side lands exactly on that left side. Okay? Now, if a graph is symmetric to the y-axis, we call that an even function. And y'all, that's because graphs that are symmetric to the y-axis have even exponents. So that's what we mean by even function, okay? All right, y'all, so let's look at one that would do that. So y'all, parabolas that we've been playing with, on this parabola, if I was to take it and fold it across that y-axis, this right side would land on the left side. So that's what we're talking about. That y-axis is sort of cutting it in half. All righty. The second one is going to be symmetric to the x-axis. And y'all, it's similar to the y-axis, but this time we're going to fold it over the x-axis. So if folding the graph over the x-axis and the graph lands on itself. All right, also a picture of a x-axis would be a graph that sort of does like this. If I was to take this graph and fold it across that x-axis, the top part of my graph would land on the bottom part of my graph. So basically, the x-axis is cutting it in half. So, y'all, I'm out of axes. So the last one is what we call symmetric to the origin. So remember, the origin of the graph is the 0, 0 in the middle. So y'all, to check this one, if rotating the graph 180 degrees, so basically turning the paper upside down, but if I rotate this graph 180 degrees and we get the same graph. Okay, and I'll show y'all an example of that in a second. Now, these are what we call odd function. So a graph that would do that, actually one that y'all been playing with is that cubic graph. It's odd exponent. So a cubic graph would come up, pass through the middle, and then it went uphill. But y'all watch this graph. If I took this and I turned it 180 degrees, y'all look here, I still got the same graph. So that's what I mean by rotating it 180 degrees, okay? So those are examples of each of these three types of symmetry. So what we're going to do, we're going to pull up MATLAB, and I want to see what y'all think on these. So I'm actually going to pull up the chat. Either that or y'all can unmute to answer me. So y'all, let's go to problem 1 in 7-1. And y'all, we'll knock these 5 out right now. So this first graph I'm showing y'all, they want to know if it's symmetric to the x-axis, y-axis, or the origin. All right, y'all, well, look here. It's not the y-axis because if you cut it in half with the y-axis and fold it over, this right side of this graph will not land on the left side. So I'm going to check the x and, all right, you got it perfect, Jahan. It's definitely the origin, right? So it's not either axis, but if you turn that graph upside down, this bottom part will end up here on the top and look exactly the same. So y'all, that one is definitely the origin. All right, y'all, let me make this next one bigger and see what y'all think on it. So x-axis, y-axis, origin are both the x-axis and y-axis. So y'all, what are we saying? And y'all look at that. Y'all look at that y-axis on this. So y'all got definitely the y-axis perfect. Because y'all, the y-axis is actually cutting it in half. And if you folded it over, that right side will land exactly on that left side. All right, let's see what we got here. All right, y'all. So this is going to go one by one. Is that graph symmetric to the x-axis? Yes or no? All right, so y'all got yes on that one. So y'all, you're going to put yes and then check that. Is it symmetric to the y-axis? All right, y'all, quick on that. No, good job. And y'all, finally, is it symmetric to the origin? All right, look, that was pretty quick, so that is definitely a no on that. If that one was turned upside down, it would be opening to the right, not opening to the left like it is. So y'all, good job. Now let's see what y'all remember about even or odd. So if it's an even function, it is going to be symmetric to the y-axis. If it's an odd function, it's going to be symmetric to the origin. And y'all check this out. Y'all see how many times that graph is touching the x-axis? That's another way you can tell. It'll either touch the x-axis, an even number, or an odd number. So this one here, if I was to fold it over the y-axis, it would land on itself. So it would be an even function. Also, y'all, it's touching the x-axis 2 times. That's an even number. So y'all, that is definitely an even function. All right, y'all, this one's on y'all. Is this function even or odd? So it's either going to be symmetric to the y-axis or symmetric to the origin. Also, count how many times it's touching the x-axis. 1, 2, 3, 4, 5. So it is definitely an odd. Good job. And y'all, it touched it 5 times, which is an odd number also, okay? So y'all, then you would check that. And we're done with 7-1. So let's look at 7-2. So y'all, what's going to help you in 7-2 if you want to know the shapes of these graphs in the folder for this week, it'll have the basic graphs. You can print this off and use this on the test if you want. Just to help you remember what the 7 basic graphs look like. This is the line graph. This is a parabola for the x squared. This is a square root of x. This one is the x cubed. Next, I got a cube root of x. This is 1 over x, which we call a reciprocal. And then finally, absolute value. In 7-2, we're going to take these basic graphs and we're going to move them up and down, left and right, and do a reflection. So y'all, if you want, like I said, you can use this on your next test if you need help with the basic graphs. Okay? All righty, so let's get into 7-2 transformations. All right, so the very first transformation we'll look at is a vertical shift. So vertical shift, I'm moving the graph up or I'm moving it down, okay? Straight up or straight down. So to get a vertical shift, we have y equals f of x plus or minus some number. So you got your function and you're adding or subtracting a number from it. If b is positive, so if you're adding a positive number to the end of the function, it's going to move that graph up. Okay, an example of that would be y equals x squared plus 4. It's taking the x squared basic graph and moving this one up 4 units by adding that 4. Y'all, if that b is negative, so if I subtract a number at the end, it's going to move my graph down. So an example of that would be y equals x squared minus 5. This would take the x squared basic graph and move it down 5 units. Okay? All right, the next move. Horizontal shift, which is going to go left or right. So y'all watch the difference here. To move it left or right, you'll have y equals f of x plus a. But notice, up here, the x was by itself of the function. You just added a number at the end. On this one, you're changing the x before you even evaluate the function. So there's two cases on this. If the A is positive, and y'all, this is where it's sort of backwards to me, but if you add to the X, it actually moves the graph to the left. So it's going to move left. Y'all, an example of that is going to be y equals x plus 3 squared. So look up here. To move up or down, you did the squaring part first, and then you added the number. Here, you're adding the number to the x before you square it, okay? So if the number is inside the parentheses, you're going to go left or right. If the number is outside and there's no parentheses, then you're going to go up or down, okay? So that means if the A is negative, so I'm subtracting from the X, y'all, that's actually going to move me to the right. So an example of that would be y equals x minus 6 squared. So this, subtracting 6 from my x on this one, would move my graph 6 units to the right. All right, y'all, the last move is a reflection over the x-axis. Okay? Reflection over the x. We're not reflecting anything over the y-axis in this chapter, okay? Only the x-axis. So that would be y equals negative f of x. So y'all, an example of that, y equals negative x squared. X squared graphs look like a U-shaped parabola, but when we threw a negative in front of it, and y'all seen that on that last test, when I put a negative in front of the x squared, it flipped it over like an upside down parabola, okay? So that negative just takes the graph and flips it over the x-axis. So y'all, these are the three moves we're looking at, and we're going to be moving those basic graphs. So we're going to get in here and knock out 7.2 on the homework. All right, y'all, so let me pull it up. All right, y'all, so now y'all should be seeing my 7.2 homework. So look at this first one. We're going to describe how the given function can be obtained from one of the basic graphs. Now, since that's got an exponent 2 there, this would be the x squared basic graph that looks like a parabola. And y'all, I'm just looking because of that exponent there. So, you got to tell it what basic graph you're starting with, and then choose A, B, C, or D based on what we said subtracting 8 from the x will do. So, y'all, I gave y'all the three moves. If I subtracted from the x, is it going to move my graph left, right, up, or down? And remember, I'm inside those parentheses. So y'all, it's going to definitely move it right. So we got to come down here and pick D on this one, the one that said it moved it to the right. And in the little box, you got to put your x squared. So put the x and then square it. So you got to tell it the basic graph that you're dealing with, okay? Now watch this. You're going to check that answer. And then we got to graph this. So click on the enlarge graph. All right, first of all, we got to pick the tool we would use. Well, y'all, I'm going to pick the x squared tool, the U-shaped parabola. Now, you don't got to plot any points. Get over here on the graph and click anywhere. No matter where you click, it'll start the graph in the center like a basic graph. All right, you see a little box that popped up. Y'all, you can ignore the vertical stretch and shrink. We're not doing that. You can ignore the horizontal stretch and shrink. We're not doing that. We're going to be doing the vertical shift, horizontal shift, or reflected over the x-axis. You can ignore the reflect over the y-axis. So y'all, since y'all said that was going right, I'm going to take the horizontal, that's your left or right, and move it right 8 units. So y'all, once I move that, look, my graph was in the center. That moved my graph to the right. So once I've moved my graph using the scale, I save that and check my answer. All right, y'all, this one has an X on it. So I'll show y'all real quick. I'll share that page real quick. The one that has the equals X is the identity function, which is the straight line. Okay? So, going back to that problem, this will be the straight line graph. So they're subtracting 3 at the end. It's not in parentheses. So by subtracting 3, is that going to move me up, down, left, or right? Then I'll be able to pick my A, B, or C, or D. So y'all, since this is not in parentheses, it's going to go down. So good job. So let's see, that would be A for this one. And then we're starting with the graph y equals x. So y'all just going to follow the same pattern on the homework as I'm doing. This one will be the line graph for y'all. So check your answer. Now, y'all, this is the only one. You're going to choose the line tool. This is the only one you actually got to plot 2 points. Okay? So I would just come up with different x values, subtract 3 to get the y values. So I'm going to let my first x equal 3. If I put a 3 in for that x, 3 minus 3 gives me 0 for the y. So my first point would be 3, 0. Now if I put a 0 in for that x, 0 minus 3 would give me a negative 3. So my second point, I'm going to do 0, negative 3. But y'all look, the line should go right to the center. That moved it down 3 units like we said. Okay, so remember, on that graph, you can pick any 2 x values you want. Okay? Plot your 2 points and it'll draw the line for you. Check that. And then we're moving on. All right, y'all, the 1 over x, let me show y'all the basic graph on it. So for the 1 over x, the basic graph is this one right here. So now, going back into the math lab, and they're telling you it starts with the graph of 1 over x. So what I need to know, what is that plus 3 doing to this graph? Is it going to go left, up, down, or right? And y'all, once again, that plus 3 is not inside parentheses. So darn good job. That was definitely going to go up. All right, y'all. So we check that. Now on this one, they're not going to make you graph it. You just got to pick one of these three pictures. And y'all, I'll tell you something. This B right here, B is the basic graph. So it's either going to be A went up or C went up. So y'all, what are y'all picking? All right, good job. I would pick C also. So see how C is up above? And it looks like A would have been if it was being subtracted, okay? All right, y'all check that. Next question. All right, y'all, this one's a cube. Exponent of 3 would be the cubic graph. So y'all, let me show you this cubic graph real quick. So my cubic graph was the one that sort of went uphill, left to right, okay? All righty. So I got a negative in front, x plus 10 in parentheses, all cubed. So first of all, that plus 10 inside the parentheses, left, right. Well, y'all, if you look at the four answers, it can only be right or left on that one. So by adding 10, did I go right or did I go left 10 units? And y'all, if you look on the horizontal, when I added, it went left. Now, that negative in front reflects me over the x-axis. And y'all look, they got y-axis on C and x-axis on D. We need to go with D because the only axis we're flipping over is the x-axis, okay? So 10 left, flip it over to x-axis. Now here we got to put in our x cubed because x cubed was our basic graph. All right, y'all, I will check that answer and then we're going to graph it. So click on to enlarge your graph. The cubic tool is the second one on the second row. So click that. Click anywhere on the graph. And down here on the boxes, we said it went left 10. So take that horizontal and pull that over to negative 10. And y'all, we reflect it over the x-axis. So the bottom left corner, check that box and watch it. Watch my graph as I uncheck it and check it. It was going uphill. Now it looks like it's going downhill left to right. Save that and then check your answer. All right, y'all, check out this and we're going to describe it, then graph it. So since you got an exponent 2 on that, this will be the x squared graph. All right, y'all, this is on y'all. You're going to shift it blank 5 units. That 5 is being added to the x inside those parentheses. So would y'all pick right, up, left, or down? All right, so y'all going to go left on that. Good job. And then you're going to shift it blank 4 units. Left, down, up, or right. So that plus 4 at the end, what is that doing? So that's going to go up. Good job. So you would choose up on that one. Check your answer. That's going to make me graph that. So I'm going to click to enlarge my graph. I'm going to grab the U-shaped parabola for the x squared tool. I'm going to click anywhere on the graph. It always starts it in the middle. All right, y'all said left 5. So y'all that horizontal, go to negative 5. And then y'all said up 4. So take your vertical and go to positive 4. If you notice, my graph now moved left and up. So y'all save that and then check your answer. All right, y'all, so let me tell you something about these square roots. If the number is under the square root, you would treat it like it's in parentheses. So under the square root with the x, you would treat that like parentheses. So y'all are telling you you're starting with the square root of x graph. So by adding 7 inside the radical like that, or the square root, y'all might call it, by adding 7, that's going to make me go left. Because that's like it's inside parentheses, okay? It's sort of understood. Now, that would go left 7 units. So y'all check that. All right, this one will have 3 pictures to choose from. And y'all, I'll show you the square root graph real quick. So y'all, the square root graph is the third one on the top. It starts in the center and sort of slowly goes uphill to the right. So what I need to know is which one of these pictures went left 7 units. You got A, you got B, you got C, or you got D. All right, so which one of those 4 looks like they went left? And y'all, that looks like C. That's what I'm going to go with too. If you notice it, they usually start in the center, but that one went left where it's starting, okay? So you would check that answer. All right, y'all, this is the cube root. So the cube root sort of looks like the square root, but it goes both directions. So they're subtracting 4. But y'all look here. That 4 being subtracted is not under that cube root. It's on the outside of it. So what do y'all think subtracting 4 is going to do when it's on the outside of the function? Is that going to move me up, down, left, or right? All right, y'all. So not right because this one's not under the square root. So you wouldn't treat this one like it was actually in parentheses, okay? So this minus 4 is not in parentheses with the x since it's not underneath it. So when you got the function and you subtract 4 at the end, y'all, that's actually going to make this graph go down. Okay? For this one to go left or right, it would have to be the cube root, and the x minus 4 would all have to be under that cube root, okay? All righty, y'all, so check the answer. All righty. So y'all, B is the basic graph for the cube root. B is the basic graph. I need one that goes down. If you look at A, it looks like that one went up. But y'all, if you look at C, that one actually looks like it went down. So we would put C on that one and do our final check. All right, y'all, this is our last one for section 7-2. They got a negative x minus 2 in parentheses squared plus 5. They're telling you you're going to start with the x squared graph. You're going to shift it blank units. So these are all saying left and right for the answers. So to go left or right, it's got to be in parentheses. And the only thing in parentheses is that minus 2. So that minus 2 inside parentheses, is it going to go right 2 or left 2? All right, Darren, you got right, so I'm going to put right 2 there. All righty. Then you're going to reflect it across the x-axis or the y-axis. And y'all, I think there was only one that we did on this one, so which one was it? So the x, so pick x, y'all. All right, y'all, then that up 2, down 2, down 5, up 5. Want to go up or down? They're looking at that plus 5. So y'all, plus 5, am I going up or down? So go up. Y'all about that? Up. Good job. Y'all, this one you just got to check the answer and be done. All right, y'all. So that is 7-2. So next we get to play with. All right, let me get my paper ready. Y'all, this is 7.4. And we're going to be dealing with quadratic equations. Now, quadratic equations come in the form of this. Ax squared plus bx plus c equal to 0. Okay, so this is the form when you got a quadratic equation. That x squared term is what's making this quadratic. So when we solve these, we want everything on one side equal to 0. Y'all, in this class, we set everything equal to 0. Now, I'm going to do a little bit of review with y'all before I actually break out this quadratic formula, okay? So this is just a review. Because y'all, you got to be able to simplify these square roots if you're going to be playing with this quadratic formula when I give it to you, okay? So y'all, here's my first question. What is the square root of 4? Right, this is on y'all. So what would y'all give me for the square root of 4? Okay, 2. There's one answer. I need another answer for the square root of 4. What other number times itself will give me a 4? Right, y'all, 2 times 2 is 4. That's one of them. But y'all, there is another answer for this. -2. Good job. So y'all, a positive 2 times 2 is 4. -2 times -2 is 4. So both of these answers will work. And y'all, if you want to use shorthand, that's where we use a plus or minus 2. Plus or minus 2 is shorthand for positive 2 and -2, okay? All right, square root of 25. And y'all, guess what? It'll have two answers also. All right, Carly got one of them. Give me another one. So what other number times itself equals 25? Y'all got -5. Good job. Or I could have said plus or -5 on that, okay? All righty. So here comes your first curveball. Square root of 20. Y'all notice this. 20 is not a perfect square. There is not a number times itself that'll give me 20. So this is not a perfect square, but you got to be able to simplify this. So we still must simplify. Simplify. We got to simplify it by removing any factors that are perfect squares. So y'all let me put a list over here of perfect squares. One is a perfect square because it's 1 times 1, but that won't help me on this problem. The next perfect square is 4 because that's 2 times 2. 3 times 3 is 9. 4 times 4 is 16. 5 times 5. 6 times 6. 7 times 7. 8 times 8. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. Hey y'all, what is 12 times 12? So 144. And that's probably high enough on those. But other than the 1, because y'all, 1 don't really help me on these problems, these are my perfect squares. So to simplify this square root of 20, I got to remove any factors that might be a perfect square. So do y'all see a factor of 20? That is a perfect square. So 4 is a perfect square. Good job. So y'all, what you would do, since 4 is a perfect square, you would write your square root of 4 times square root of 5. So 4 times 5 under these radicals equals 20. So y'all, the reason we had to break out that square root of 4 is because it's a perfect square. So what would the square root of 4 be? And y'all are saying the square root of 4 is 2. So the simplified form is going to be 2 square root of 5. Now, the 5 does not have any of these factors to make a 5. Actually, 5 is a prime number. So we know this one cannot simplify any further. Now, y'all, this one could also be a plus or minus 2 square root of 5, okay? So now that we're dealing with equations, we got to take into account positive and negatives for those. So y'all, let's see what y'all do on this one. Square root of 45. 45 is not a perfect square, but does it have a factor that is a perfect square? And y'all are saying, yes, it does, because there's a 9 sitting here. So 9 is a factor of 45, so I'd make that a square root of 9 times the square root of 5. So y'all, the final answer, square root of 9 is 3, and then bring down your square root of 5. And once again, this would be a plus or minus. All right, y'all, one more. for y'all to do, and then I'll do some, I'm going to throw some negatives under there. So 50, not a perfect square. It's not in the list. Does 50 have a factor that is a perfect square? And if so, what number? All right, 25, good job. So I'll make this 25 and 2. See, while they're both under the radicals, they got to equal 50 if you multiply them. All right, y'all, so let's take the square root of 25, and that'll technically give me a plus or minus 5 square root of 2. All righty, y'all. What is the square root of a negative 4? So guess what? We cannot take the square root of a negative number because if you multiply the same thing times itself, like signs always make this positive. So since this is negative, we can't take the square root of it as it looks in the real world. So y'all, let me show you what we would do. We would make this a square root of 4 times the square root of negative 1. Now, by definition, when we see a square root of negative 1, we're going to replace that with an I. That I means this answer is now what we call imaginary. This is where you get your imaginary numbers, is by trying to take square roots of negative numbers. And y'all, let me show you something. Remember this square root graph a while ago? That's why this only goes in the positive x direction. Since the negative x's, if you put negative numbers under there, this is imaginary. So that's why this graph don't have nothing on the left side of it. Okay? Because we can't graph imaginary numbers, we can only graph our real numbers. Hey, also, guess what I'm going to get? I'm going to get a square root of 4 is 2. Square root of negative 1 I can't take, but I'm going to replace it with an I. So if you're taking a square root of a negative number, you're going to get an imaginary answer. All right, so try this one. Square root of a negative 49. So what do y'all think that square root of a negative 49 is going to give me? All right, y'all, don't be shy. All right, y'all do that just like we did here. 49 is a perfect square right here. So let's make this a square root of 49 times a square root of negative 1. You're always going to break out that negative 1, and that's going to become the I. So square root of 49 will give you 7. Square root of negative 1 gives you the I. All right, I'm going to do one more, and then we'll get in with our quadratic formula. Square root of negative 20. All right, I'm still looking for perfect squares. And y'all, we actually did positive 20 right here. So we know 4 and 5 are the factors I need. But since this is negative, I'm going to put my square root of 4, my square root of negative 1, then my square root of 5. I always put the negative 1 in the middle. If you put it at the end, if you accidentally put the I under what's left, under that radical, it'll mark it wrong, okay? You can put it at the end, but it cannot be under the radical. So y'all watch this. Square root of 4 is 2. Square root of negative 1 is I. And at the end, I got a square root of 5. All right, y'all, that's my review on this because we're about to play with a big formula and it's got a big square root on it, okay? So we're about to start solving quadratic equations. So to solve quadratic equations, I'm going to use the quadratic formula. Okay? So given ax squared plus bx plus c equals to 0, the solutions can be given by, all right, y'all ready? Here comes the quadratic formula. You got an x equals negative b. So whatever sign b is in your formula, that is going to change it to the opposite. That's what that minus is there for. And then you got a plus or minus square root. So see, they got a plus and minus coming out of this square root like I showed you a while ago. That's how I'm going to get to two different answers. I'm going to add what this gives me the first time to get my answer. Second time, I'll subtract what this gives me. Now, under this square root, you got a b squared minus 4 times a times c. Everything is over 2 times a. So hopefully this is bringing back memories, okay? Now, the quadratic formula will solve any quadratic equation. Some quadratic equations can be solved by factoring, but y'all, if you can't get it to factor, you got to use a quadratic formula to get them answers, okay? So y'all, let's play with some examples. And they call this, solutions are also called zeros. And the reason we call them zeros is because we're setting it equal to 0, okay? All right, so let's play with our first one. I got f of r equals r squared plus 8r plus 15. So the first thing I'm going to do is set that equal to 0. Now, y'all, this one would factor. If you like factoring, this would factor. But we're focusing on this quadratic equation, okay? So the first thing I got to find out are what is my A going to be, my B, and my C before I plug them in. A is in front of the R squared here. Y'all don't see a number in front of that R squared. So what number would y'all put for A? Actually, what number is in front of any variable when it don't have a number there? All right, y'all got 1 there. So A is definitely a 1. B is a positive 8. C will be a positive 15. We're going to plug these numbers into this formula. So I got my X equals negative. So y'all write that negative first and then put in your B. Well, the B I'm putting in is a positive 8. So that negative turned the positive 8 into a negative 8. That's all it's going to do is change the sign of B, okay? All right, next we got a plus or minus. We got a square root. B squared. Well, y'all, B is 8, so I'm going to put my 8 in. Square that. And then it's got a minus 4 times A, which is 1, times C, which is 15. And y'all, all of that is over 2 times A, which is 1. So all I did was put numbers in for these letters according to what we had right here. All righty. Well, y'all, that negative made this a -8 like we said, so you can't do nothing there at the moment. You're going to notice most of the work is going to be under here. All right, so 8 squared. What is 8 times 8? All right, that gives you 64. Now, y'all look at this. All of this right here is getting multiplied. There's a -4 times a 1 times a 15. What, multiplying all three of those, will that give us? All right, 60. And y'all, that's going to be negative, right? We're still subtracting all of this. So since you got one negative, it's going to keep it negative and then subtract that 60 like you said. And y'all look here on the bottom. 2 times 1 is 2. All right, we're continuing on. We got this -8 plus or minus. Y'all, the only thing I can do on this step is do that subtraction. 64 minus 60 will leave me a 4 up under that square root, all over 2. All right, y'all. So the next thing, you got a single number under that square root. So now you're going to take that square root. So bring down that -8 plus or minus square root of 4 is 2. And y'all, that's all over 2 on the bottom. So now I'm at a point where I can't do nothing but get my first and second answers. All right, y'all, watch this. To get the first answer, I'm going to take that -8. I'm going to add 2 and then divide by 2. So the first time through here to get my first answer, I'm going to use the plus here. All right, y'all, let's figure out what that'll give us. -8 plus 2 is -6 divided by 2. -6 divided by 2 gives you a -3. If you put a -3 in for these r's, it will equal 0. All right, let's get our second answer. And y'all, let me tell you this. When you're solving equations, the highest exponent in the equation tells you how many answers you got to get, okay? Now, since I added that to get the first answer, I'm now going to go through and subtract my 2. So I'm going to do -8 minus 2 divided by 2. Well, -8 minus 2 is a -10 divided by 2, which gives me a -5. So if you put a -5 in for the r's, it will equal 0 when you evaluate it. So the answers are going to be x equals -3, comma, -5. So the ones that could have been factored, y'all could have factored this one by x plus 3, x plus 5, and then set them equal to 0 to get these two answers. A little bit in the future, I'm going to work on y'all on factoring more. But for right now, I'm showing you how to get the answers using your quadratic formula. All right, y'all, let's do more. All right, y'all, this one has f of x equals x squared minus 2x minus 4. Now, this one you couldn't have factored anyway, so the only way to do this one is the quadratic formula. So I'm going to set it equal to 0. And y'all, what I need are A, B, and C. So give me my A, B, and C on this one, y'all. All right, 1, good job. -2, good job. -4, good job. All right, y'all, so we're going to plug them into our formula. So I'll write my formula back up here again. -b plus or minus square root b squared minus 4ac all over 2a. All righty, so here we go. Negative b, which is a -2. So I always put my negative numbers in parentheses. Plus or minus square root b squared, that's going to be -2 squared, minus 4 times a, which is 1, c, which is a -4, all that over 2 times a, which was a 1. All right, y'all, look here. Negative times a negative makes that a +2. So once again, whatever sign your b is, that negative will change it. All right, y'all, let's work under the square root. -2 squared is a +4. Any number you square will be positive on that part. All right, y'all. All this is being multiplied. You got a -4 times 1 times -4. When you got two negatives like this, that's going to make that a positive. And then 4 times 4 gives you 16. All of that, 2 times 1 is 2. All right, y'all, we're going to work under the radical now. That's the only thing I can work on now. 4 plus 16, give me 20 under my square root. All over 2. Whoops. All righty. I'm going to bring down my 2 plus or minus. So y'all on the side, let's do some side work. We need to see if we can simplify this square root of 20. So y'all remember them perfect squares I had a while ago? 4, 9, 16, 25, 36. But the perfect square that was a factor of 20 is going to be a 4. So I'd make that square root of 4 times square root of 5. I would go even further because I know the square root of 4 is 2. And then bring down my square root of 5. So y'all, that's why I showed y'all that while ago, simplifying these, because y'all right there it is. So the square root of 20 I'm going to replace with a 2 square root of 5 all over 2. Now y'all, I want y'all to notice something. These three numbers on the outside, both of these numbers on the outside will divide by that number on the bottom. Now, you cannot divide a number under a square root by a number not under a square root. So this 2 can only divide by numbers on the outside, okay? So watch what this is going to simplify. 2 divided by 2 gives me 1 plus or minus. 2 divided by 2 is 1 square root of 5. Remember, I don't have to write that 1, okay? It's understood to be a 1 in front of it. So y'all, there's your 2 answers. First answer is 1 plus square root of 5. Second answer is going to be 1 minus square root of 5. Now, you can put it in MathLab like that, or you can use the plus or minus. So I usually use the plus or minus and put 1 plus or minus square root of 5. Okay? But you can put them in 1 plus square root of 5, comma, 1 minus square root of 5 if you want to. Good, y'all. So, look here, this quadratic formula can solve any quadratic equation, okay? So I'm going to do a couple more examples and then I'll let y'all be on your own, okay? All right. This next example, x squared plus 3x minus 5 equals 0. They want exact solutions and they want approximate solutions. So approximate solutions would be decimal answers. And let's see, they want me to go 3 decimal places. And y'all, sadly, this is where you got to have a calculator to do this approximation, okay? So first, let's solve it. We'll get our exact answers, and then I'll show you how to get these approximations. So A is 1, B is 3, C is negative 5. So y'all, let's plug them in. X equals negative B, which is 3, plus or minus square root. B squared would be 3 squared minus 4 times A, which is 1, and C, which is a negative 5. All that over 2 times A, which is 1. So we're going to play with this. Now, exact solutions means the radical answers. So we'll get our exact answers first. So bring down that negative 3, plus or minus. All right, let me work under this square root. 3 times 3 is 9. And y'all look at this. You got 3 things being multiplied. You got 2 negatives. So 2 negatives will make that a positive. And negative 4 times 1 is negative 4. Times negative 5 is a positive 20. All of that over 2 times 1, which is 2. All right, y'all, here we go. Adding them under the radical. So negative 3 plus or minus under the square root, 9 and 20 give me 29. All over 2. All right, so we're at the point where we need to try and simplify this square root of 29. So y'all, here's my perfect squares. And so on and so on. Are any of these perfect squares, other than 1, remember we said 1 don't matter, Are any of them numbers a factor of 29? So can you multiply 4 times something to get a 29? Can you multiply 9 times something to get a 29? Can you multiply 16 times something to get a 29? Are any of these numbers factors of 29? No. So since none of these numbers are factors, this does not simplify. So y'all, since that does not simplify, this is my final answer. And if you use the plus or minus, that's both answers in one, okay? Now, when you put this answer in Math Lab, the first thing you want to do is choose the fraction first. Okay, then when you got the fraction chosen, on top, put your -3, plus or minus. Click on the square root icon it gives you, put that 29 in, then arrow down to the bottom and put the 2 in, okay? So these are the two exact answers. Now, let me show you how to get the approximations. To get the approximations, I'm going to be plugging this in the calculator. The first time I'll add, second time I will subtract. So y'all watch how I do this on that calculator. Now remember, we got around this 3 decimal places. So the first thing I'm going to do is get my fraction by hitting the green alpha button, y equals, and enter. On top, I had a -3, so use the negative in parentheses. I'm going to do plus first. All right, over here on the left side by the x squared, you got a blue radical. So hit the second blue button and the x squared. It'll pull the square root up there. Put in 29. Then arrow to the bottom and put in a 2. So this will give me my first answer when I add. And y'all, I get 1.19. So the 2 is in the third decimal place. Would y'all keep that a 2 or would y'all turn that into a 3? Because remember, we have to go 3 decimal places after the decimal. So I'm going to make that a 3, y'all, because after the 2 is a 5. And anytime it's 5 or higher, you round the number up. So I would make that a 1.193. All right, let me get the other answer. Alpha y equals enter. All right, on top I got -3 minus second x squared to get the square root. Put my 29 in, arrow to the bottom, and put a 2. Y'all, what's nice about these is you're going to notice something about these answers. So when I hit enter, I get -4, but y'all look at the decimal. The decimal is the same. Okay, the only differences are usually the numbers in front of the decimal. So that's going to be what, a -4.193. All right, y'all. So it's going to ask for exact. I would probably use the plus or minus for this one instead of trying to write this twice like I was putting it in the calculator. And then these are the approximations you would put in. 1.193, comma, -4.193. Okay, so approximations and then exact. All right, y'all, so I'm just going to do one more with you to show you something different on this one, and then I'll be done with you, okay? All righty, so let me turn this paper. It's sort of flipping up. All right, y'all, so this one they're giving me f of x equals 5x squared minus a x plus 10. All right, I'm going to set all that equal to 0. All right, y'all are going to help me on this one because the first thing I need from y'all is A, B, and C. All right, y'all, A, B, and C. All right, 5, -1, and 10. Good job. Whoops. 5, -1, and 10. All right, good job. So I just made it mark there. That's bad. All right, y'all got A, B, and C. Let's plug them in. Negative B, which is a -1, plus or minus square root, -1 squared, minus 4 times A, which is 5, times C, which is 10, all over 2 times 5. All right, y'all, so let's see. That negative times negative is going to make that a +1, plus or minus. So a lot of my work's under here again. So -1 times -1 is a +1. And y'all look at this. All this is getting multiplied. There's only one negative. So since there's only one negative, that's going to stay negative. Woo, y'all, let's see what we got here. That's going to be a big number, right? 4 times 5 is 20. 20 times 10 is 200. So I got 1 minus 200 all over 2 times 5, which is 10. Hey, y'all, we got to work this radical. So I get 1 plus or minus square root. All right, y'all, so what's going under the radical? So 100 minus 20, 1 minus 200 is a negative 199 all over my 10. All right, so we're down to the radical. On the side, we're going to try to simplify that square root of negative 199. So y'all remember your numbers: 4, 9, 16, 25, 36, and so on. Are any of them factors of 199? You know, I'm going to show y'all a trick to find factors of a number. Watch what I do on this calculator. So I'm going to share my calculator. All right, I'm going to clear everything. I'm going to go to y equals. So the number I'm looking for factors is 199. So watch what I do. I'm going to take 199 and I'm going to divide by x. Whatever number you want factors of, divide by x, and then you're going to go to the table. Second graph to go to the table. All right, y'all, so 0 is not a factor. So 1 times 199 is a factor. And y'all, if you arrow down through here, everything else is decimals. You see that? Everything else is decimals. So they're not factors of 199. So it looks like the only factors of 199, let me go back up here, are going to be 1 times 199, which means it's a prime number. Okay? So if you want to find factors, take the number, divide by x, and look on your table. Now, none of these numbers are, none of them are perfect squares or factors, but y'all, I can't keep that negative under that square root. So you at least have to bring out that -1. If it's negative, you got to bring that negative out so that this will give you a square root of 199. And y'all, I usually put my I in the front. You can put it after, but it cannot be under the radical, okay? So you got to arrow out of the square root before you put the I if you put it at the end. So now, replacing this with that, I get 1 plus or minus I square root of 199 all over 10. So y'all, here's the thing about this one, and the reason I wanted to show you this one, when you got imaginary answers, so imaginary answers must be written in A plus BI form. So this is what you would call a complex number. It's got a real part, it's got an imaginary part. We all hear my real part is 1 over 10. That's my A. And then I got a plus or minus square root of 199 over 10 I. So you can either write it like this. So this is your real part and your imaginary part. Or it should take it like this. 1 over 10 plus or minus I square root of 199 over 10. But y'all, what you realize is everything on top is over that 10. Okay? So when you split a fraction apart, they're both still over the 10, okay? All right, so one of these two ways is how you would put it in if you got an imaginary. So y'all, if this negative under this square root, break the negative out as an I, and then write it in A plus BI form. All righty, do y'all have any questions? So I'm looking on chat. Any questions at all, pop them on my chat for me. So what y'all think about that quadratic formula? And y'all, the trick is getting them square roots simplified, okay? Once you get the square root simplified, they're not too bad. But that is the trick, and you got to remember them perfect squares. I would keep that list. My 4, 9, 16, 25, and so forth. I would keep up with that list on these, okay? All right, I'm going to quit the record and